Okay. So in previous exam, we saw these different data types, and they were all simple data types in the sense that they have a simple value, and when you make an assignment, their value is copied. Are you with me now? So an assignment such as this just generally meant that you take the value of that specific variable, make a copy of the variable, assign it to the new one. So in this case, x and y are totally different, independent, fully realized variables. They have no relationship with each other. There was a moment they had the same value, but they are totally different. And this is true for all the other data types that we have seen, like tuples. So if you had this, even though x and y have the same value, they actually are stored, their value is stored in different places. So if I were to change x to, it has no effect on y. The problem is that you do not want to do that for things like lists and sets. No, sets are not in the exam, but this is also true. And even for images, even though they are not in the I don't have any questions on the exam, because they may have huge values. So when you create a copy, that it will really slow down your program to create the copy, and you may run out of memory. So as a result, by default, the program is not going to create a copy of the object. So if your list was, for example, let's write it here. So if your list was like this, and when you do this, it doesn't really create a copy of x. It just says that let x and y point to the same list. So in this case, y is an alias to x. So what that means is that x and y are just different names for the same thing. If you change x, it will also change y because they are actually the same exact thing. There is no difference between them. So if you wanted to check this, you can append something to x, and then you can print x, and you can print y, and they should really be the same. Even though I have not actually changed y explicitly, x and y are the same thing. So we have seen that there are lots of functions that also take a list and change the list. So in that case, I don't create a new list, I just basically access a list and then change the contents. But if you wanted to actually create a copy of everything in the list and assign it to a new list, you would use one of these things called shallow copy operators. Why it's shallow copy, I will talk in a second. So for example, one way you can do that is list of x. It will take every single value in x, create a copy of it, okay, but a shallow copy. And now z is a copy of the elements in x, but they are not identical. So if I were to change x and change z, they should really be independent copies now. Okay. So in fact, if you wanted to see, x and y are still the same thing, but z is a totally different element. So I copied x to z after I changed x, and then after that point, they diverged. So z and x are different things. So the other way you can do that is by slicing. So you can take a list and you can slice it. So the slicing basically says, take a list and take a subset of items from the list and create a copy. So the copy is exactly the same way. So for example, the slicing generally works like a start value, an end value, and an increment. Okay. So for example, if I wanted to slice x from 1 till 3, increment, let's say 5, incrementing by 2, what would that mean? That I will basically take x of 1. I need to take the first element. Then I'm going to increment it by 2, so I'm going to have x of 3. Then I'm going to increment it by 2, which is going to be x of 5. But the endpoint is non-inclusive. So since everything starts with 0, generally the last valid index is the length of a list minus 1. So it's always done in such a way that the last value is not inclusive. First value is always inclusive. So I don't want x of 5, so this will only give me x of 1 and x of 3. So if you want to see if that is true, we can do the slicing like this. Okay. Okay. So I took the value at x of 1, which was 2, x of 3 was 4, and then that was it. I didn't take 200 because the last index is not included. So if you did not put the start on end, so so if you put no starting value, something like this, it is assumed that you start at 0, go up to end. So that means start at 0, go up to end minus 1. So if I wanted to do, for example, x of 4, which means that I'm going to take, well, let's just do x of 3. X of 0, x of 1, x of 2, but not x of 3 because that's not included. So now if you did not put a starting point, you cannot put an increment because, is that true? Actually, I'm not sure if that's true. So let's try. I think it still does work. It does work, okay. So if you wanted to go all the way to the end from a starting point, so you can do something like this. That you start at begin and go all the way to the end. So if I had print, for example, x of 4 to the end, I have x of 4. Is there an x of 5? Yeah. Okay. So the slicing is such that it actually creates a shallow copy. So for example, in this case, if you give no starting and end points, that means take everything in the list. This is the same as list of x because you are actually making a copy of everything in the list. Okay. So so that is on slicing. Well, how about shallow copy versus non-shallow copy? Because I keep saying shallow copy, right? There's a reason why I'm saying there's actually a thing called a deep copy. That all depends on what the list stores. So if the list actually stores values, like A, B, and C, then you're making a copy because if you were to take that value, you would actually make a copy of it with assignment. But if you have a list of lists, so let's say, let's get a new list. So in this case, I have a list of lists. And if I were to, of course, make this, A, B, C, and D, E, F are pointing to the same value. If I were to do this, That means I take the values in ABC and make a copy of them in DEF. Okay. So for the practical purpose of they being different lists is true, right? So I can actually take ABC and append the new value, let's say 5 and 6. So those values will not actually be in list of ABC. Thank you. Yes, let's make that ABC2. That was a very good catch. I really thank you for that. I would have looked at that for a while. Thank you. Da, 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 da. I am still working on this. Okay. There we go. So you see that ABC and ABC2 are different things because I made a copy. But the interesting point is that inside ABC were lists, right? I did not actually create a copy of those lists because by default, I don't create a copy of a list. So the shallow copy will only make a copy of the first level. So what that would mean is that if I were to change, for example, a value, okay, okay, you see that when I change a value in the list inside ABC, that still is actually not a copy. Okay, so for the exam, this is not important that you understand this. That, you know, I don't have any questions that would require this kind of thing, but what I'm saying is that when I say shallow copy, it's the copy in the first level, not all the way. So if you have a list of lists, when I create a copy of it, it still creates a copy of the first level. If in the first level of the list, you happen to have a list, I'm only going to create an alias to it. So lists are never copied by default. The only thing that does it, there is a deep copy function that will do that. Okay, so that's much for that. Any questions on slicing? So now slicing will work the same way for lists or strings. So strings and lists will basically do the same exact thing. And you can take a list. I had this whole question on the exam based on the movie Martian. It was about you had potatoes, you have to grow potatoes and eat potatoes. But it turned out that question was too difficult, so we actually don't have that question. So, but I'm going to use the potato-based question for my example here. So if you have a list, you have a string called Marshall, right? So you can address the string in the same way you address the list. So you can have x of 1. You can slice it. You can slice it a bit more. And every single time you slice a string, you get the substring that this one addresses in the same way. So remember, the list indices start at 0, go all the way to the length minus 1, if you're going in the positive direction. Or in the negative direction, they start at -1, go all the way to negative of length. But this is the same thing with strings, but there is a big difference between strings and lists. In the strings, you cannot change a value, right? You cannot address and change a value, but you can take a string and slice a subset of it. Now, the most beautiful thing about slicing is that slicing never gives an error. If you give it a bad slice, then it will just return you nothing, which is nice. So, for example, you can slice negatively. So if you wanted to slice from -1 to -3, but you have to write it in the correct way, right? So you want to slice starting from -3 up to -1, you should really write it like this. Okay. You cannot go from -3 to 0. You cannot go around the circle. If you're going to go all the way to the end, just not put the -1. Or you can write an increment. So you can say that if you want to, I'm going to start from -1 all the way to the beginning, but increment by negatively. So now what it did is it actually went -1, -2, -3, and then gave you the reverse of the string, which happens to be just a trick. But I do know that you care about this, so I'll put it here. So if you were to do the same thing, if you actually were counting the slice negatively, it would also give you the list in the reverse order. So if you had so if you were, for example, to do indexing like this, it would go from there. Otherwise, it would actually reverse the list. And if you were to give a, totally unreasonable thing, like, slice from 3 to 2, which is not possible, it will just give you an empty list, which is nice. Or if you were to give a invalid, index, it will give you just all the way to the end and then stop. Slicing is very nice. The next thing, yes? So -1 this is the increment, right? So it says start from -1, go all the way to the end. Okay, so I know you're already in -1. Start at -1, go all the way to the end, but incrementing negatively. If you're incrementing negatively, it's going actually to the beginning, right? So that is actually the beginning of the list. All right, I don't know. So you're saying that you want to do this like -1? Yeah. So it just says, I think this should probably give you the same result. Yeah. Because since it's -1, it knows enough that your beginning is actually the end, which is very deep, as I understand. What else? Okay, so the other thing that I was asked was split and strip. Very important. So let's do, so let's kind of partially do the homework that had the candidates. That was actually a remaking of something involving World Cup soccer from last year. But, World Cup soccer, people told me that they hated doing so many homeworks on soccer, so we changed it. I don't know why. So, okay. So let's do candidate 1 and candidate 2. So what I want to get is states 1, tide, and representatives. Okay. So basically, I am going to enter something like, far 5 and 25. Okay. So what I'm entering is a string like this. So in the string, you have 3 values, right? But they are separated by a comma. So if I want to now address individual fields, what I can do is I can write a split function. Okay, it is written exactly like this, and give the delimiter. So it will be a comma in this case. So it could be any delimiter. If you did not put anything, the delimiter is generally space. Okay, so space is by default. For everything else, you need to put it. If you wanted to split by space and write explicitly, you can do that. And so what it will do is it will take every part of the string before and after a comma and will return you a list containing that. So let's do it like this. So M will be like this. Now, if I actually had a string, this is actually an important distinction that ended with a comma. Okay? When I split, it will actually have an empty string right after the comma, because it's going to have a string before and after each of these. So this is only important that for those of you who just don't do file I/O like I tell you to, and then you read it and you split it, and you will end up with that final empty string because after the new line there is one more. Once you come to it in the lab and ask why, I will tell you I told you so. So remember that when you do a split, what you get is basically a list, right? But a list of strings. So if you wanted to actually change these so that they are valid, meaning that they are integers, you actually have to convert them one by one. So what I would do in such a case is I would actually write a function for getting the values from something like this. Okay, so what I would like to do is, I believe I saved this as a txt. Okay, there we go. So I am going to take C1, and I'm going to split it on comma. Okay. For this homework, it happens that you actually need to have integer values. So I'm going to convert them to integers. So this brings up the other thing that I keep telling you not to do. So if you wanted to do, so now M is this list, right? So your first instinct is going to be write something like for item in M, item is equal to item dot integer of item. Then I'm going to return M. Okay. So, will this convert the values into the into integer? This is one of the most common errors that I see. In fact, I generally see something like this. Okay? So something like this. So let's go through this and fix it. So first of all, when I do this, I will get value M is not defined. Well, because I actually did not do anything. All right? But anytime you have a split, it returns you a list, but you have to assign it to a variable, right? Okay. Now I am going to shorten this because I cannot see what it says. All right, there we go. And I'm going to say 1, 2, 3. And it still returns me as a string. Why does it return these results as a string? Because whenever you do a for loop for item in M, you take a value from the list, you copy it to item. Now, item has the copy of the value, but it doesn't really go and change what is in the list, right? Because item is a copy of the value. The values happen to be just strings. So this is kind of what we were trying to talk about here, that when you have a list, right, So, and then you say y is equal to x. X and y are the same list, so if I were to change something in x, x and y are both changed. But if I say that x is 0, let's assign it to z, x of 0 is what kind of value? It's an integer. So since it's an integer, whenever I make an assignment, I create a copy of the value. Happens to be 1. I am going to add some values. Z is 4. But it has not really changed inside the list because it is not a pointer to what's in the list. It's a copy of the value itself. So if you really want to change something inside a list using a loop, you should really index that list. You can do it either for loop or while loop. It really doesn't matter. I'll do it with while loop first. So while I is less than length of m, I am going to have the fact that m of I should actually be int of m of I. And then I'm going to increment I. Okay. So anytime you have to change something inside the list, I recommend that you index it using this. So if you don't want to use a while loop, you can do the same thing with a for loop. So for I in range of length of m, okay. The nice thing about this is that it allows you to write a shorter program, but ultimately the result is the same. So let's do the same thing for the second candidate. So I am going to do copy and paste. Okay. Now you see that basically whenever I actually use functions, my program is much simpler to write. I don't even have to invent a new variable. I can just use the same variable. When it becomes more costly to create new variables, this actually will work better. Okay. Something like this. Okay. So when you are writing a new program and you want to actually test it, you can actually stop the input, so you can just write what you want to do right here. Let's say 8, 4, and 10. Okay. So that we can write the rest of the program that you were asking. So the other thing that, so this kind of all I wanted to say about split. Do you have any questions? Yes. It may or may not be. But it is for you to realize when you read something, whether information that you want is in that string, or do you need to take that string and split it so you can use parts of it. Okay? Yes? This function? Okay, so basically we have three different ways of writing loops, right? I mean, there's the while loop and a for loop, right? But the for loop is a little more tricky. So we kind of understand the while loop. So the while loop is written in such a way that you basically have a condition something like this, right? So when you're writing a while loop, you need to make sure that you actually have a valid condition. You actually go into the loop once, and then your loop changes and you go out of the loop eventually, right? So we have seen kind of various types of loops. The easiest loop that we have seen was that you count. So, you want to set I to be something that is less than, that the while loop is true. If it's not less than 10 to start with, it will never be true. And if you don't increment it starting from 0, it will never be 10, right? So you have to make sure that your loop is basically first it is correct. So if I actually, so it's a simple one. If I started with 10, I will never actually enter my loop. If I start from 0, but instead of incrementing, I decrement my loop, it's going to never end, right? What I found that you can actually change this, and it stops. Okay. And sometimes you actually write loops that by default actually are never supposed to end until you tell it to stop. So for example, I always use a Boolean like this. I'm just taking a shortcut and then I'll come back to what I was doing. So I'm going to print the command, and then if command is equal to stop, I am going to set finished equals to true. This is still an infinite loop, except that it will end, and since it asks for my input every time, it's not going to go forever. So you can do the same kind of thing. You can type anything you want until you type stop. It will print stop, and then it will end, because at this point I set this condition to be true. Then while not finished becomes false, and it does exit my loop. When you're writing a for loop, for loops are different. In for loops, you don't really have something you are changing. You basically generally have a list, and you iterate over the list. So all for loops in Python are iterating over different types of collections. So we know that we can write for loops to iterate over, for example, items and lists. We can iterate over items and sets. I can also iterate over, what else? Lines and files, right? So whenever you have a for loop like that, for loop is going on its own, but it has a collection of something it's iterating over. So for example, you could be iterating over I'm going to put alpaca, because I saw some cute alpaca pictures this weekend. All right, so if you say for animal in animals, okay, basically it will take every single item from that list, copy it to animal, and then print the value of animal. Will the items in the list be capitalized? Well, if I print animals again, will they be capitalized? No. All right, good. Make sure you know why. All right. So if I wanted to iterate over a file, I will open the file and then iterate over the items. If I wanted to iterate over the indices of a list, I need to first create a list of indices. So to be able to do that, we learned that there's a function called range that creates a range of values. So by default, so this is the same principle as slicing, the same exact thing we talked about. So the range has a starting point, an ending point, 8 is not included, and an increment, right? So if you don't give the increment is 1. If you don't give the starting point is 0. Now for ranges, you cannot do range of 8 increment of 2, because this will think that what you're trying to do is you're creating a range of numbers from 8 down to 2, which there is no such number, so this is an empty range, right? So if you really wanted to do count negative, you have to have the negative increment. But the whole point is that you basically create a list of integers to serve as indices. Then you can use those indices to iterate over a list. So you can, generally, if you're doing a list, and if you want to access all the lists, so then you create a range starting from 0 index up to the length of the list, but not including the final item. So generally, this is what you would do. So what you can say is, for example, and I'm going to comment this out so that I don't have to worry about this either. Okay. So will this change the values in the list? Yes, it will, right? So anytime you have a for loop, you either are iterating over the actual values or you're iterating over the indices. But real Python programmers never use any of these, just FYI. Once you start to become kind of proficient, instead of being a programmer, you become a Python programmer, they never use it. They actually use a thing called enumerate. Have you ever heard of this? So in fact, enumerate will create you an index and a value together. So for I and animal in enumerate animals. It will actually do both of them at the same time. So once you become comfortable, you can learn about this thing called enumerate. I don't do it in CS1 because it would just be confusing. But anyway, all right, I'll stop doing this. Are you with me so far? Okay, so let's go back to this one. All right, so candidate 1 and candidate 2 are basically two lists of items. So what I can do is I want to figure out who's a winner based on these two variables, right? So basically the thing that was asked in the homework was that you look at all possible outcomes up to 4, right? So you wanted to basically have a way to look at all possible ways person 1 can win and person 2 can win. So in this case, I am going to look at all outcomes starting with 0 up to, was it 5 or 4? Okay. And then I'm going to see what happens if candidate 1 gets 0 representatives and candidate 2 gets 5 representatives. Okay, or candidate 1 gets 0, candidate 2 gets 1. And I'm going to look at all possible combinations. Anytime you have a program that requires all possible combinations, that's when you need a double loop. Okay? But almost all other cases, you will always need a single loop. So Sudoku board required a double loop, but scanning a file once will only need a single loop. If I ask you to find all possible pairs of words or possible pairs of points and distance between them, that requires a double loop. There is no such question in this exam, but there will be in the next exam. But a lot of things will require only a single loop. But in this case, since I want to look at all possible combinations of two values, it does require a double loop. So if you are basically doing something like this, I start very slowly. First, I would like to print information so I can see whether I can print this board reasonably, right? So these are all possible outcomes. So what I want to do is I want to print all possible outcomes. So for example, I did this for Sudoku also, but I'm going to basically look at, and I'm going to put this space right here. Okay. So I am basically printing this information so that I can see, I'm looking at all possible ways to pair two things. So, but we want to print one line on top and one line to the side of this. So on the top, I'm going to have values from 0 to 4. I'm going to write a separate loop for that. So for I in range of 5. And you see that I always use a string for these because it's much more complicated to remember where to put the space. So I'm going to take the I, make it a string, and then right justify it by 3. This is 1, 2, 3, 4. Okay. And then print line. Okay. So this is good. So now I have 1, 2, 3 here. And maybe I should put 4 spaces here. So that means when I start, for each line, I will put actually str of I, right, justified by 4. So it will put a space right here. Right? So now I'll make sure that these are also right justified. It's by 4, so I am going to take this and right justify it by 4. Looks reasonable. If you want it to be actually even more generic, you can actually have spacing as a variable. And anytime you have 4, you actually use the spacing. So this way, you can actually adjust this as you go along. You see, though, that I don't add that at first. As I know what I'm doing, I can actually adjust this. So I can actually change the spacing to 6 to see if it looks nicer. So, okay, so now what I want to do, though, at each point, I want to print out the outcome of the result, given that you have candidate 1, candidate 2, and the new outcome is 0, 0, something like this, right? So what I want to do is write a function that takes candidate 1, candidate 2. It's becoming way too long, so I'm going to call C1, C2, outcome 1, and outcome 2. Okay? And I want to figure out the points for the first person. So it's going to be C0 of 1 times 5 plus C2 of, well, we can even do better. So we can say, let's create a copy of C1. Let's create a copy of C2. I actually did not solve this, so I'm solving it in front of you. So you can see how I go about, I try something, doesn't work, I try something else. So now if outcome 1 is greater than outcome 2, then I'm going to add C1 copy of 0 plus 1. That means the first person won another state. If outcome 2 is greater than outcome 1, C1, then the C2 copy is going to win another state. Else, they are both tied, so C1 copy of 1 and C2 copy of 1. And I'm also going to add the representatives to both of them. Okay. So now all I need to do, look at who the winner is. So I'm going to have points 1 is going to be C1 copy of 0 times 5 plus C1 copy of 1 times 2 plus C1 copy of -1 divided by 2. The same thing is true for 2. Are you at all following what I'm doing? So if points 1 is greater than points 2, I'm going to return 1. If points 2 is greater than points 1, I'm going to return 2. Else, I'm going to return 0. Okay? So now that basically I created the information as a list, but if I were to change that list in the function, it will actually change the list, because whenever you send a list as a parameter, it also is an alias to the actual list. So because of that, I created a copy, like we talked, and then I added the new outcome. I computed my points, and then I returned this. So then all I need to do is, in here, instead of printing all of this stuff, I just need to take this function and find the outcome and I and j, and then print that one. Okay, and now you have to test. So you have to reduce this so that you see if somebody wins in different conditions. You need to reduce it enough so that eventually somebody wins. Instead of actually changing this person, I should probably be changing this person. Okay. So then you have to do debugging. So, any questions so far about what I've done? So let's see to the list and then see where we are. Okay, I kind of talked about this. Okay, so we talked about these two. I talked about this, talked about this. Are you satisfied with double loops? Let's hope so. All right. So let me talk a little bit more about alias versus copy. It's like Alien versus Terminator. So the final thing to remember is that whenever you are, so we talked about how if you create a list, and then make an alias, x and y are the alias of the same. Now, one of the things that can happen is that you can also write functions to access lists. So, for example, I can have something like this. So I can say, for example, so this is kind of a function that, you should start getting comfortable with. I'm not saying this is like a great function, but let's kind of talk about it, and then we can do different things. So L is a list. I read a value from raw input, and if the value is valid, I insert it to my list. Does this return anything? No. So this function doesn't return anything. As a result, since it returns nothing, I want to call it like this. Okay? Not like this. If I call it like this, after I run this function, the value of x will be none because the function returns nothing. So I want to call it like this. In fact, I am going to call this function 5 times, like this. Okay. Do we have a bird in the room? Where is this bird? It's a hinge? Okay, it was like this really, okay. There is actually a bird that lives in the Albany airport. Have you ever seen that? Okay, all right. So, so when I call the function, it asks for a value. I enter a value. It converts it to an integer. If it's between 0 and 10, it enters it. And I'm supposed to do this 5 times. Now, I read 12, but 12 is not greater than. And -1 should not work. And 20 should not work. Okay. Now, the thing is that even though my function doesn't return something, I am actually passing the list as a variable, right? So, because this x is a list, when I pass it to my function, this is an L, right? L becomes an alias for this list, right? So, as a result, L, if I change L itself, then it also changes x. Now, a lot of you, when you write functions for the first time and you have a, let's say, a variable like x, instead of writing it like this, you actually don't do this, and you just do this. And it will work for lists, but it will not work for other variables. But this is not something we want you to do because this will not work in other programming languages. Plus, this is actually very bad programming experience. So if you work in a team, your team members will hate you. You may hate yourself eventually as well because it's very hard to debug. But overall, I don't want you to program like this. This is why we keep taking points off in the homeworks when you do this. So even if you do have a list as a global variable, you must pass it to your function as an argument because when I look at my function, I should see all the values that I need to access in the parameters. So this is what we want. Okay? This way, I've separated this function from everything else. In fact, I can take this function and use it in other programs without it having to depend on something else. So we want your functions to be self-defined and modular. Well, self-contained and modular. Okay? So I want you to write programs that look like this. But the functions can access a list if you pass it as a parameter. Remember that whatever you do when you change it in the function, they also change outside in the outside world. But here's an interesting but very tricky point. Now again, this is not needed for the exam, but as you start to do more exciting things, you will also get more exciting errors. So here's another one. So let's say that you passed L, you read some variable L, but then the first thing you do in your function is now L is assigned to some empty list. Okay? So here's what happened. When you passed X and call the function with X, when you first call the function, X and L point to the same list, right? But then in your function, you suddenly decided that, no, I don't want L to look at this. I'm going to create a different sandbox for L. L will play here. And then when I finish the program, I'm going to come out and then finished. But I did not actually change X because now L is pointing to a totally new place, right? When I do this, L and X are no longer aliases. They were in the very beginning, but then I totally ruined the whole thing. So now, no matter what you do, this is not going to change X because you no longer are pointing to the same thing. Now your instinct when you see this error would be to get rid of L and just use a global variable. I want you to fight this urge and learn to not do this. Okay? So now L and X point to the same thing, so when I change L, it will also change X. If I change L to point to something else, that will no longer be true, okay? If you are confused about this, go back. I also explained this in my exam review, common mistakes, so hopefully, eventually you will get comfortable with this one. Okay, so I wanted to do that. So remember that anytime you pass a list as an argument to a function, then that list, that variable, the local variable, is an alias for the list itself. Okay, so now I want to do a little bit of file I/O, okay, as was requested. And I'm going to do some complex parsing, not needed for the exam, but it may help you with the lab that's coming up. Okay. So when you're working with files, we basically learned three basic things. It's very, very simple. So you open a file, you read the file, generally line by line. Yes, you can read the file as a whole, but don't do that. But there are reasons for doing that. I'll tell you in a second. And then when you're finished, you close the file. In the same way, when you write a file, you open the file, you put line by line, okay? And then when you're finished, you close the file. When you're writing, you must close a file because otherwise your changes may not be saved depending on how your operating system works. So remember two things. When you're reading a line from a file, it reads it with the new line behind, new line at the end, right? So the first thing we always learn is so f dot read line reads a new line at the end, reads the line with the new line. At the end. If you're writing a file, you must put the new line, otherwise it's not going to put a new line. So you must include the new line in each line you write. If you have programmed in other languages, there is a write line. There is no write line in Python. Now, you do know that there are many random ways of doing other things, but I think this is enough. So remember that when you do f.open, it takes your pointer f and points it to the first line. And when you do a read line, it keeps moving it one line below until you come to the end. One of the very common things that you would do is open a file. Let's do this one. If you don't put a read, it is by default opened by read. If you want to open it by write, you have to explicitly put write. You can also open it by append by adding to the end. And then you do generally do something like this. So for line in F, this will keep repeating a read line. So even though you're not actually writing read line, it actually is doing a read line. So for line in F is the same as do f.readLine, assign the string to line until you come to the end of the file. Okay? And this line itself is actually going to have a new line too. So I am going to save this in the same place where I actually have some file that will help the one request that I have left for okay. So I have this file called census data, which I actually provided earlier on. I don't know if you still remember it, but it looks like this. So each line in the file is a location, population in 2010, and population in 2014. And I believe the lines here end with actually new line, which is good. But this file is actually kind of strange. This was given in CS1 maybe 2 years ago as a homework, maybe given again, unless I solve it now. So you generally have information for a county. Then you have all the cities and towns in that county until you actually see another county, right? So if I wanted to find all the towns and cities inside Albany, they are right after I find Albany County until I find the next county. So this is exactly like what you would have to do to read the paragraph and line numbers, right? Because paragraph and line numbers mean that you first read all the lines until you are at the end of a paragraph. Then you know you're at the end of a paragraph, so you're going to skip all the lines until you start a new paragraph, okay? So this is kind of the same thing. If I were to see a city, like a Broome County, who's from Broome County here? Where is that?
It's down by Pennsylvania, like just above the border.
Oh yeah? All right, so I learned something. So if I want to find all the towns and cities in Broome County, first you have to find Broome County, and then continue scanning down, okay? So let's write that program, just so that you can see how to do such a thing. Okay, so if I were to run this, the first thing you will see is you have these empty lines. Because every line I read has a new line, so you have a new line and then a new line for print, right? If you wanted to get rid of stuff from the ends of the strings, you can use strip. Python is nice. There's a thing called strip, which will strip new line, space, and tab from two ends of the string, but not from the middle, right? If you wanted to only strip a certain thing, you can write what you want to strip. This should give you the same result, okay? So the first thing that I would like to do is figure out all the fields that I want. So basically, I am going to take the line and split it on, I think, tab. Okay. And so location is actually m of 0. And I'm going to just look at the last population, m of -1, and it's actually like this. And I am going to, actually I'm going to strip this. You don't have to, but I will. Okay. And I'm going to only print the location and the strip. Okay. Now the first thing you will find is that it's giving me an error for the first line, because in the first line you actually have a header, so you don't actually have a number, right? So what I want is to skip the first line, but do this for all the lines. This is where having the break and continue really helps. So I'm going to have a line counter. And for every line I read, I'm going to increment it. And when it is actually 1, I am going to skip, meaning that I'm not even going to do everything else. Okay? So that means read every line except for the first line, skip the first line, meaning continue means skip everything below this, go to the next line. Okay? Now it complains that this is not a valid integer because it has commas, right? Because the numbers here actually have commas, all right? So what I should do is, when I take the population, I'm going to replace all the commas with nothing. Okay, so I can do this. All right, so now it seems to work. So, so now I have a location and the population. So I can print that. I can print that in nice ways, right? So I can have something like this, for example. Okay, looks okay. So now we want to actually figure out everything for a certain county. So now this is reading every single line, but I don't want to read the whole thing. I want to read everything for a specific county. So let's ask for the county. So Now, I'm going to read a county. And you see that county is written like Tioga County, right? So I'm going to check if location is equal to county. If so, I'm going to print this. Will this work? Well, if I write Albany County, it will work. If I type Albany, will it work? No. Well, if you want, you can do it in few different ways. So for example, you can take the county and you can strip the space and then add county at the end. You can even capitalize to make sure that it works. Okay. You should obviously assign it to here. You can even check if county, or I would say if county in county dot lower, else I'm going to take county and there are many different ways you can do error checking. That's up to you. Now this should work in many different ways, except it doesn't. Is it not Albany County? That's true. Thank you. All right. It is much easier to type with all of you helping me. Okay. All right. So my promise was that not only I will show what is in that county, but everything below that county until I reach to a new county. Okay. So what I'm going to do is I'm going to keep track of this by a flag. Okay. So I am going to have a flag called started. I'm not going to start printing things until I start this, right? Whenever I find the county, now the started is going to be true, right? Because I actually found the county. Okay? So when I found the county, I start this true, and when I'm actually started, I can print all the other information below that county, right? As soon as it turns true, Albany County, I'm going to print things. Okay? So it's going to print things. Okay? Okay? So it printed Albany County, and then it started printing everything below Albany County, but it didn't stop. Right? It didn't stop because I didn't tell it to stop when I reached something else. When do I know I reached something else? When I see another county, right? So if I started printing and I found that county is in location, I'm going to set started to false. Okay, so this is not going to work, and we will talk about that why. Okay. So when I see Albany and it is started, I'm going to print these two. Okay. But if I'm going to write it like this. If I find another county that is not Albany County, I know that I should stop printing, so I'm going to say started is equal to false. Okay? And I should probably do that before this, because otherwise I will keep doing it. Okay? And I'm going to do Broome County. Like this. Does that sound correct? Okay. Now, one of the last things you will have to do, this is very similar to what you're going to do for the lab. One of the things you have to do is look at these conditions to see if you can simplify them. Because I checked the same thing multiple times, you can rearrange the if statement to make it more efficient. But that's like the last thing you have to do. First, you have to make it so that it is correct. Okay? So there's nothing like this in the exam, obviously. But I wanted to show you that when you're doing file parsing, it doesn't require double loops or anything. It just requires you to keep track of things with booleans. Okay? Now, please write using big letters and a dark pencil, because when we scan, we cannot see it. And good luck in the exam.